Injection moulding is one of the most common plastic commercial manufacturing processes. From this diagram you can see it's a fairly simple process. The yellow Archimedes screw is driven forward by a hydraulic ram. This allows the plastic granules from the hopper to be fed along the main chamber and heated until molten. It is then injected into the two-part mould, and the little green rectangles you can see are the ejector pins to help eject the part. What are the features of injection moulding? The top of this spray has been injection moulded. I know because of the complexity of its shape. It has got high detail, a lovely smooth finish. On here we can see that there's a high level of detail required for this mechanism to work. It also has spray and stop on the sides. So these symbols and labels help us identify that this was injection moulded. Something that can be difficult to find in products is a split line. Some manufacturers are very careful and they will have where their mould splits be the bottom of the product so it is not seen. But in this kitchen knife, under the right light, if I turn it, we can see the split line runs the whole way up, and this is where the two parts of the mould separated. Again, in this car, the plastic part has been injection moulded. I know through the high level of detail, the symbols and labels. This circle is an ejection point. This is where it would have been pushed out of the mould. Some more of these products have obvious features, high level of detail. What this has that's quite obvious is some flashing where the material has spilled over the edge. As you can see, the material has already been inserted, clamped in place and heated in this video. What you can see is the mould being raised and then the vacuum turned on, and thus the part is taking its shape. It will then be cooled, released from the mould and cut out. This packaging has been vacuum formed. I know because of its thin walls. I can also see that it's got draft angles. So this is offset and the internal angles are also offset. Now this has no clear indication of symbols or labels, but if we look inside this chocolate packaging, and I just take out this nice chocolate, underneath you will see that it has got the food safe symbol. So again, this one's got a bit more texture and pattern about it, but again it's got thin walls and draft angles. The plastic powder is loaded into the mould. The mould is then heated inside an oven and the mould spins on all axes. This allows the plastic powder to coat the inner lining of the mould. Once the mould is fully coated, it is cooled and then the inners can be removed. For rotational moulding, you can see some examples of products. We've all seen a slide. It's one colour, it's one piece construction, and it's hollow inside so that it's lightweight for children to lift. Now, some other products are oil tanks. Some of the features of injection moulding are what we've mentioned already: hollow, one piece construction, one colour. Now, if we look at this, some of them are seamless. So depending on where the mould splits, depends on where the split line will be and how seamless it appears to be. Some products have built-in fixings. I know this might be a bit difficult to see, but on the kayak, it's got ropes going left to right. These will require fixings, which will be built in. Again, these products all have a high quality surface finish. I think a lot of us will have used these products, felt these products, and we can recognize their qualities. Sandcasting is a rather simple process. The metal will be heated up in the crucible until molten. A pattern will be used which is an exact replica of the shape to be cast. The box that it will be cast in is split up into two parts: the cope, which is the top of the box, and the drag, which is the bottom of the box. The pattern is inserted and it is packed out with sand. We use a parting powder so that the cope and the drag do not stick together. Sprue pins will be inserted, which allows a runner and a riser to be formed. The runner is where you will pour the molten metal in, and the riser allows the molten metal to rise. When the part is cast, you will then remove the riser and the runner. Sandcasting is a process that many of us will recognise. I'll go through that just in a moment, but first, this is a really good example of a sandcast part. You can see that it's got a low quality surface finish. It's a bit pitted and it looks textured like the sand. Some of the other features are flashing. That's whenever the material seeps through the edge or the seam of the join and it has to be cleaned up. That might be a little bit of flashing there. Split lines will be apparent, although we can't see them here, and draft angles will be used so that it's easy to remove from the mold. Now, as I mentioned, some of us might recognize products that we didn't know were sandcast. If you go to the gym, you'll have seen these weight stacks. They're often sandcast. And we've all seen those cool videos on YouTube of people sandcasting the Batman fidget spinner and things. If you watch those videos, you'll see some examples of flashing. The die casting process is somewhat similar to injection molding. The molten metal flows into an injection barrel and through pressure is forced into the two-part mold. The part is formed inside the two-part mold, allowed to cool, and ejector pins will be used to eject the part. This Land Rover has been die cast. It has a high quality surface finish and a high level of detail. They have used draft angles so that it is easy to remove from the mould. Inside the door you can see split lines. Somewhere there may be symbols and labels, but these will be hard to find due to the paint finish. They will use bosses, which are little objects to secure an internal thread, or will have an internal diameter that allow two parts to easily fit together, and they may use ribs for extra strength. Looking at these components, these have also been die cast. If we look closely at one of these nuts, you're able to see a split line along the edge. Laser cutting is a computer-aided manufacturing process. The part will be drawn in CAD, and then depending on the material, you will select your laser. There are two main types of laser, a CO2 laser and a fiber laser. The main difference is that a fiber laser can cut metals amongst other materials, whereas a CO2 laser cannot cut metals. These are some of the laser cut objects I have at home. As you can see, this high detail image has been etched on. The edges are extremely smooth and well finished. Now this shape is not complex, but the laser can cut any shape. I've also used a laser to engrave this little chopping board. "3D printing is another computer-aided manufacturing process. 3D printing involves additive manufacturing, building up layer by layer. It can be very precise. It can also take a long time, the more precise you would like it to be. 3D printing is used mainly in prototyping, but it is becoming more widely used to produce parts. Unfortunately, this is the only thing that I have 3D printed during lockdown. It's a guitar plectrum. Now you can actually see how the nozzle moved along this one, and you can see the different layer heights here. Now, I did not need a mould or a former to make this. I drew it on CAD and then I hit print. It's a not very complex shape, but it's got slight curving on it and it's very, very rigid. Some of the drawbacks were that I did not get a high quality surface finish as I wanted it quick. I was limited with the materials I could use.